Hi, my name is Daniel. Welcome to the presentation about sustainability in the paints and coatings industry. Sustainability has become a global megatrend. Why is that? Because we are actually living a great life on this planet, and every single person of us is taking up significant resources. This is taking a heavy toll on our planet, and people start thinking now about how to protect nature, how to protect the planet. And this sustainable consciousness and acting is developing more and more as the driver of our time. And that's why the concept of sustainability has become a megatrend in politics, as well as in business sectors as diverse as the chemical industry. We all know that a change is necessary in order to protect nature, because more people means increasing demands for food, water, and energy, and this is pushing nature to its limits. And we have to change that. Our biggest challenges nowadays are fighting the climate change, finding solutions for a low carbon future, and using natural resources as efficiently as possible. We at BASF have a strong commitment towards this sustainable future, and that's why we even included sustainability into our purpose, into our company claim. We create chemistry for a sustainable future. How do we want to realize this? We are basically covering every part of our value chain, from suppliers up to our customers, with sustainability activities. This starts from suppliers, where we source responsibly. This includes all our operation that we have been doing. So we produce safely for people and the environment, and we produce efficiently. And of course, for our customers, we drive sustainable solutions to enable them fulfilling their sustainability goals. And along the way, we value people and treat them with respect. In today's talk, I want to focus on the sustainable solutions that we offer for the paints and coatings industry. We are realizing this by using alternative raw materials. With them, we can manufacture the same products as the fossil ones in a more sustainable way. And here we are discerning basically between two different kinds of feedstock. That's on the left visible, the renewable feedstock section, where we can provide a dedicated bio-based portfolio, for instance, which is based on sustainably sourced resources, for instance, RSPO certified palm oil. And on the other hand, and that's where we will see a couple of examples in the upcoming slide, we have been developing a biomass balance portfolio, which is derived from biomass waste of agricultural production, crop or food processing, or residues. On the other hand, we have been developing in a corporate project a recycled feedstock approach, the so-called chem cycling project. I also have one example on that later on. Here, we focus on post-consumer plastic waste or tires and chem cycle them, so to say, into new powerful products. Let's start with the biomass balance approach, which is key for a significant CO2 reduction. Here, we are basically going back to the very, very early stage of the value chain. That means basic chemicals and even further naphtha, the origin of basically all products. The feedstock, which is fossil in the normal way, is being replaced by renewable feedstock. This can be biogas or bio-naphtha, and then fed into the BASF interconnected system, which we also call Verbund system. With this mixture, we are producing products. However, since we are producing fossil and the renewable products at the same time, one cannot exactly detect the renewable amount that is then located in the product. And that's why we need a certain system. That's the mass balance approach, where we virtually allocate what we fed in terms of sustainable feedstock we allocate this to the desired product of choice. And to make the whole process very transparent, this is not only done by BASF, but regulated and audited by external authorities. So in principle, when customers buy a so-called biomass balanced, strongly CO2 reduced product, they also earn a certificate connected to that that states from a third party that states that they saved significant amount of CO2 when buying this product. So this product is a strongly CO2 reduced one. So bottom line is we can offer both fossil products and the bio-based biomass balanced products. Let us have now a look on a couple of examples to make this more crisp. So I brought a couple of case studies with me just to underline the effect and the impact of biomass balanced products. And here you see an example from the wood coating section. If you imagine to coat a standard living room, which has about 30 square meters with a biomass balanced paint, so to say, which is basically consisting of polyurethane dispersion and acrylic dispersion as shown in this table below, then you have already for one living room a saving of 6.4 kgs of CO2. Well, some of you might say now, okay, that's about 100 kilometers driving with my car. Yes, it is, but you also have to imagine that in the whole paint and coatings industry, the impact per square meter is relatively low due to the really thin layer on top. However, the scaling effect is significant because if you're considering already a town having 10,000 living rooms, then we're talking suddenly about 1 million kilometers driving the car. So the scaling effect is significant in the paint and coatings industry, and that's why also biomass balance approach is a powerful tool to push the sustainability here. Another example is from the packaging and printing segment. So here you can look basically from two perspectives. So the first one is the number of products basically printed on. So you see on top a Flexo ink for 100,000 corrugated boxes. Here you save approximately 10 kgs of CO2 because print is only on a certain section of this box. However, then taking into account the overprint varnish for a folding carton, and here a typical OPV producer purchases about 1,000 tons per year, for instance. If you mass balance that one, then you end up with 1,100 tons of CO2 saving, which is corresponding to the savings of about 10,500 solar panels. So again, here the scaling effect is significant and the sustainability contribution is huge. Third example that I brought is related to industrial coatings, and here we had a look at electricity pylons. If you used a formulation based on a biomass balanced dispersion, with only the coating of one pylon, you would save approximately 37 kgs of CO2. And then again, you think about the scaling effect. We had here the example of Germany, which has about 150,000 electricity pylons, and suddenly you end up with 5.5 kgs of CO2 savings. And if you expanded this to Europe, then you end up with 158 kilotons of CO2 saving. So the leverage is here also significant. The second part, how to approach the paints and coatings industry in a sustainable way, is the plastic waste reduction section, which we cover with our ChemCycling project. What is that? The ChemCycling project is basically the first step into the realization of a true circular economy, because we are using post-consumer plastic waste to create new products with them. And we do it in a sustainable way, and we do it in a very powerful way, because usually if you think about recycling, the quality of the new product isn't necessarily given. In this case, it is because it's a chemical recycling. We take plastic waste or end-of-life tires. We work together with partner companies that convert this plastic waste into a kind of oil, the pyrolysis oil, to a thermochemical process. This pyrolysis oil is then purified and can be used as feedstock in our steam cracker at the beginning of BASF Verbund production. And from then on, the same allocation process, like I explained for the biomass balance concept, is taking place. And we can produce, not this time no biomass balance product, but chem cycling products that contribute to a very strong plastic waste reduction. Also here, I try to come up with an example, and this case study here is concerning a standard kitchen. Standard kitchen, as you see below, which we estimated with an area of 8 to 10 meters, and already here we have a coated surface area of approximately 70 square meters. If you coated this now completely with a chem-cycled material, you would have crude oil savings of about 10 kg. So you're already saving fossil resources with it. But more than that, you would have converted 12 to 15 kgs of plastic waste. So like this photo here above, into new paint that has the same properties and performance as paint based on fossil resources. This is due to the fact that we are changing the feedstock from the very early beginning of the value chain. So this has no influence on the performance of our products. Last but not least, to bring all this together, we've decided to also add more transparency to the whole sustainability story, because in the end, it's about saving fossil resources, and more than that, saving CO2. That's why BASF has developed a digital application for a CO2 product footprint. What does that mean? We want to create the transparency for our customers and for the whole industry by calculating the product carbon footprints of all our sales products. So we are talking now about 20,000 different raw materials, 10 terawatt hours per annum in terms of energy. This is going into 700 production plants. And we fed all this data into a huge computer system and calculated for each and every sales product that BASF has the product carbon footprint. So that means in total about 45,000 sales products. And with this data at hand, this enables our customers now to compare what their best sustainable solution for the respective application is. This is a kind of sneak into the future, and the portfolio in terms of product carbon footprint will be available in 2022. Having said this, I'm actually at the end of my presentation. I hope I could show a couple of examples how to approach the paints and coatings industry in a sustainable way. And thanks a lot for your attention, and I'm happy to answer questions. Thank you very much.
Now questions. Please ask if any question. Şurada. Evet, okay. The first question, Dr. Dan von Nessen, is compare the crude oil products. how much more expensive are the biomass products obtained from the mass balance approach?
There's of course a certain markup. This has to do with the availability of the feedstock material. So it is still not as abundant as, for instance, crude oil. On the other hand, it really depends on the single product you're talking about, because what we are doing is basically we're taking and calculating the amount of crude oil that is necessary to produce a certain sales product, and then we substitute this amount by the biomass feedstock. So it depends, of course, on the chemistry of the product, how much influence this conversion has. So in case you are interested in certain products, we surely can have a in-depth discussion on certain product or product categories. But there is no like general approach regarding this.
Another question is, if it doesn't influence the performance of the products, why don't you only produce materials from waste or bio feedstocks?
That's a good question. This for sure is something that has to do with, of course, the market demands. There are certain markets, and I sense there is a strong increase, strongly increasing interest and demand in the paints and coatings industry. But there are certainly markets where sustainability is in that child phase, so to say, at a very early stage. So that's why there will be a transition phase. You cannot basically switch from one day to another to the sources. One argument I said before is the availability and the permanent availability of feedstock. For instance, with biogas, I think in Europe the availability is pretty good already. Will be increasing, and so will the sustainable feedstock. There is certainly a transition phase to be considered. You can't do this overnight. Just as an example, we are talking when switching, for instance, a steam cracker here at Ludwigshafen site, we are talking about millions of tons of naphtha that needed to be switched. So that's why I'm talking about a transition phase, and this might take years to fully convert or partially convert even.
Another question from the same person is, compare the crude oil products, how much more expensive are the biomass products obtained from the mass balance approach?
I think we had a very similar question before, so basically the same answer applies.
May I ask you a question?
Absolutely.
Yes. It is a very interesting subject. What is the percentage in the future, near future, converting to bio-based products in coating industry? Can you guess in 10 years time or something like that?
That's a very good, but at the same time a very difficult question, because I think that at the present time there is strong dynamic, strong movement in the whole industry. So people are increasingly thinking about sustainable products. So I think the sustainability discussion per se, and this comprises now all the approaches I talked about, and also different stages in the value chain. This will be permanently growing in the next years in the chemical industry. Which technology we are offering, the ones that I was talking about, but now to talk about percentages, which technology is then in which application present, I think that's a bit too early to decide on. There we will see in the near future where we will go. in case of CO2 reduction, which is, in my opinion, key across all different applications, we have a very significant impact with a biomass balance approach because we are starting in a very early beginning. So I consider this as one of the most promising routes in terms of CO2 savings.
Do you know anything about replacing synthetic pigments with natural pigments for reduction, CO2 reduction, instead of using pigments, inorganic pigments, natural plants pigments in the coating industry?
I think that there are already organic pigments being discussed. So that's not part of my business, to be honest. But I think I've heard of organic pigments. On the other hand, I think it strongly depends on the application, because when you think, for instance, about automotive application, where the coating has to withstand strong sunlight and strong weathering effects, then you have to decide on probably the lifetime of those pigments, whether you choose inorganic or organic ones, or so I think it's going to be independent. It's going to be dependent on the application.
Okay, there are two more questions.
Okay.
Interesting question. Do you plan to integrate or share your CO2 footprint data with commercially available LCA softwares?
As far as I know, we are sharing or we are planning to share this data only with our customers, since it's quite a sensitive information about the respective product, which is then shared with the customer. So as far as I know, there is no attempt to make it kind of public via these LCA softwares.
Another question is very interesting, actually. Have you already launched sustainable products for coating industry? If yes, maybe be more specific by providing commercial names.
Yes, we've been continuously launching sustainable products, and due to the fact that the properties of biomass balanced products are the very same, the name of these products are very similar to the names of the fossil versions, but we included then 2 letters, MB for mass balance, just to discern and make it also transparent for our bookings. So we've launched waterborne dispersions, acrylic dispersions, so that John Grills in BASF brand name. I think it's way more than 10 different products, and also in the range of UV resins. So the Laromer range in the BASF brand world, we also launched more than 10 mass balance products so far. More to come. So we are continuously working on that topic.
Thank you very much for nice and interesting talk. I think we will be hearing a lot of talk in the future about this subject. Actually, thank you very much.
Thank you very much.